All right, today we're diving into something that sounds like it's straight out of science fiction. We're talking about a story where quantum physics, believe it or not, meets the very, very beginning of life. It's a whole new way to understand the silent, secret world of development before we're even born, and it all kicks off with one big question. It's one of the biggest questions in all of biology. We've always known that genetics, nutrition, they all play a huge role. But what if there's another architect in there, a hidden builder that's shaping our minds from the absolute first moment? And boom, there it is. The answer comes from a recent, pretty stunning discovery out of Michigan State University. It turns out it's not just our DNA. It's these tiny, single-celled organisms, microbes, that are playing an absolutely critical role. And this one finding, well, it's the launch pad for everything we're about to get into. So let's start right there with that foundational discovery. Because before we can even begin to talk about the incredible technology, you have to understand the biological mystery it was built to solve. The findings from this study are just staggering. What the research showed was that a mother's microbes are absolutely essential for building a vital part of a fetal brain, a region called the paraventricular nucleus, or PVN for short. But here's the real kicker. In sterile, germ-free environments where these microbes were absent, the fetuses suffered permanent neuron loss. And the damage was irreversible. You couldn't just add the microbes back in after birth and fix it. That developmental window, it had already closed for good. So, this discovery, as amazing as it was, left scientists with a monumental challenge. I mean, if this microbial conversation is so important, but it's happening invisibly, in the absolute earliest stages of development, how on earth could you ever listen in? How could you watch this blueprint being drawn in real time without messing the whole thing up? And that is where the technology comes in, an incredible new tool designed to do exactly that, to navigate the quantum scale world of these microbes and, for the first time, make their secret conversation visible. So, meet the Navigator. That little mu symbol, pronounced micro, gives you a hint of the tiny world it explores. The simplest way to think about it is as an incredibly sensitive scanner, one that's designed to pick up the absolute faintest signals of life. So how in the world does it work? Well, it measures something called the biophotonic phase, or delta phi. What it's really doing is shining a light through a biological system and measuring the unbelievably subtle way that light shifts or changes phase as it passes through. You can really think of this signal as a fundamental vital sign. It's the signature of life itself. So, the device's core ability is actually pretty simple, but it's incredibly powerful. You point it at a living system, like a microbial biofilm, and bam, you get a clear, positive signal. Then you point it at something sterile and non-living, and you get nothing, a null signal. This basic check for life is the foundation for everything else it can do. But, okay, just detecting life, that wasn't enough. The Mu Navigator was powerful, for sure, but a recent breakthrough is what took it from being an interesting tool to a truly revolutionary one. It gave the device a true biological starting point. And that breakthrough has a name, the prenatal zero set. Inspired by that MSU study, researchers realized they could calibrate this device to the very first microbial signal they could detect during fetal development. This signal, delta phi 0, becomes the absolute baseline, the point zero that all other measurements are compared against. It's like perfectly tuning an instrument before a symphony even begins. This is the game changer, right here. It's the shift from floating relative data to anchored, meaningful data. Before, measurements were just kind of hanging out there without any real context. But now, by anchoring every single measurement to that prenatal zero set, scientists can track development from its true origin with just incredible precision. And when I say precision, I mean it. This device is engineered to an unbelievable standard. It has a maximum signal drift of 1.0 or less over a full 24 hours. To put that in perspective, that's like having a microphone so sensitive it can record a whisper from across a room, but so stable that it picks up zero background static. It means you can be sure every signal you're getting is the real deal. Now look, having a revolutionary piece of tech is one thing, but proving it actually works in a real, complex biological situation, that's a whole other ballgame. So let's move on to the experiment designed to do just that. The proposed experiment is just so elegant and, importantly, it's non-invasive. Tiny little micro Navigator chips are placed inside a mouse fetal incubator. They never even touch the fetus. Then researchers set up 3 different groups of pregnant mice and just listen. They monitor the signals to see if they can actually detect these different microbial conversations happening. The whole test really hinges on these 3 groups. First up, you've got the germ-free group. That's your sterile control, no microbes at all. Second, the conventional group with a totally normal microbiome. And finally, a probiotic group, which was given specific beneficial microbes to see if the device could pick up on that enhanced signal. And this wasn't just guesswork. The scientists set up super clear go, no-go criteria for success. First, the device had to tell a difference between life and sterile material. Easy enough. Second, the signal had to be stable in the groups with microbes, but degraded in the germ-free group. And finally, and this is the most exciting part, the signal patterns had to line up with known milestones in brain development within a really tight 1 to 2 day window. So, let's imagine the experiment works perfectly. What does all of this actually mean? Let's zoom out a bit and look at the profound implications of being able to listen in on day 0. Well, this brings us full circle, right back to the beginning. This technology reinforces the urgency of that initial discovery from MSU. By letting us see just how active and important this prenatal microbial conversation is, it really highlights the stakes. It suggests that this is a one-time developmental window. If you miss it, it might be missed for good. The potential here is just immense. We're not talking about just a new gadget. This is a brand new, non-invasive window into the very first moments of life. It's a way to monitor critical early development without interfering. And it's a tool that could fundamentally deepen our understanding of the microbial partnership that defines who we are from day 0. Which, of course, leaves us with one last absolutely fascinating question to ponder. If this invisible world of microbes is busy shaping our brains before we're even born, orchestrating such a critical piece of our development, what other secrets are they keeping? What else have we just not learned how to listen for yet?